All right, we've gone over all the different types of ways that we can do stoichiometry, but now let's see how we can actually apply it by doing multi-step problems and figuring out from starting to ending how much we can predict, how much we need, and that kind of situation. So this says how many liters of gas can be produced, how many liters of gas of H2S can be produced from 36 grams of hydrochloric acid. Alright, so we'll say that our starting stuff is A, and my ending stuff, my liters of gas, that's going to be B. So my gas is B, hydrochloric acid is A. Now let's go look at the map. So we're starting off with mass of A. That's number 1. The only thing that can come after mass is mole. So that's going to be box number 2. But we're still in substance A. I need to go to the other color if I want to go to substance B. So I'm going to need mole B. But at the end of the day, I don't want moles. I want volume of gas. So box number 4 is going to be volume of gas. If I'm going to use my conversion factors, I know that I need 1 mole is molar mass because that's grams. That's going to get me from the mass of hydrochloric acid to moles. And then I'm going to have to go from mole to mole because based on our map, from here we're going to go from mole to mole. The map says use coefficients from balanced equation. That's going to be this one right here. But at the end of the day, I don't want mole B. I want liters of gas. So I'm going to have 3 conversion factors I'm going to have to use. So we say we're going to mass, mole, liters. So we're starting off with grams of A. We said we were going to go to moles of A, then we're going to do moles of B, but we want liters at the end of the day. So based on the conversion factor, we know 1 mole is molar mass. So I have my mole right there. My molar mass is going to go on the bottom. Then my grams and grams cancel. My given goes in the first box. 1 mole, we'll go find that molar mass here just in a little bit. Those cancel now. Alright, so I need a mole A on the bottom. I know mole A is equal to mole B, and I'm going to use those coefficients to figure out the number. So we'll put mole A on the bottom. Now that cancels. I'm going to go find those coefficients. For A, it's going to be 6. For B, it's going to be 3. Now I need a mole B on the bottom. And my conversion factor that we said we were going to use, we need liters of gas. 1 mole is 22.4 liters of gas. If you're looking at the map, we did the 1 mole, we did the molar mass, we used the coefficients, and we use this 1 mole at conditions, this conditions right here, because we can only use this at STP. If you got something not at STP, you should use PV equals nRT. And we'll plug this in to our formula. 1 mole, 22.4 liters. Let's go find that molar mass of A, of HCl. Alright, hydrogen is 1. Chlorine we can say is 36, or our total mole 35, and our total molar mass is 36. 1 and 35 is 36. 36 goes right there. So if you have the same numbers that are diagonal or on top of each other, they cancel out. So that 36 and that 36 cancels. So here we have 3 times 22.4 divided by 6, because those ones cancel also. So then we'll go plug that into a calculator and we'll have an answer. And we end up with 11.2 liters of H2S. All right, let's try another one. We want to know how much energy is released if 28 grams of methane react. So we're given mass and we want to know energy. All right, they gave us mass. The only thing that can come after mass is going to be moles. And we want kilojoules at the end of the day. So we're going to use that 1 mole is molar mass. We'll use those coefficients and we'll use the enthalpy. All right, so we're starting off with 28 grams. The only thing that can ever come after grams is moles. And we can go straight from moles to kJ because that's related to our balanced equation. If you don't remember the conversion factors, you can always just remember that whatever is to the diagonal goes exactly the same. Those letters, not the numbers won't be the same, but the units that are after the numbers will be the same diagonal. All right, so I know that 1 mole is molar mass, and I know that my kilojoules is moles reaction, and I got that from these conversions right here. I'm using this kilojoules one and this one that we use to convert grams. So 1 mole is my molar mass. I'll go find my molar mass of CH4 in a little bit. I know I'm going to be using the moles of reaction for CH4. No number. If there's no number, that just means 1. And my KJ, I'm going to use that delta H because that's what it said on the map. 890. Now let's go find that molar mass. All right, carbon's mass is 12. Hydrogen is 1. We said carbon was 12, hydrogen was 1, but there's 4 of those. So our total is 16 grams. So my grams cancel, my moles cancel. I'm left with kilojoules, which is what I am looking for. So we go calculate it up. We have 28 times 890 divided by 16. And then this is equal to 1557 kilojoules. That shouldn't be there. That's J. And we can either say is released, or because there is a negative sign and we're looking at energy, we can say negative. If you're looking for mass or volume or particles, those can't be negative, so you drop the negative. If you're looking for energy, you can hold the negative. A lot of times you can tell by looking at the answer choices that are given if you're going to have to worry about the negative or not. All right, anytime that you see the words limiting reactant, in your head you need to think that you have to make 2 tables. And the reason you have to make 2 tables is because you have to compare the two, because the limiting reactant is the reactant that makes the least amount of product. So that tells us if we start with 32 grams of oxygen and 32 grams of methane, how many grams of water can we make and what's the limiting reactant? So for both problems, we're starting off with mass. We're going to go to mole. We want something else, and I want the mass of that other thing. So we're going grams, mole A, mole B, grams of B. All right, grams of A, mole A, mole B, grams of B. Everybody slides down. All right, if I have grams and moles together, that conversion factor is going to be this one right here. 1 mole is molar mass. And that's what it tells me to use right there also. So from box 1 to box 2, we know that 1 mole is molar mass, and we'll call this one A for now. What is our molar mass of O2? We have oxygen is 16. If I have 2 of them, we're going to end up with 32. If I have mole A and mole B, I'm going to be using these coefficients from the balanced equation. And that's what it tells me right here also. From box 2 to box 3, use the coefficients from the balanced equation. All right, if A is oxygen, we're going to be using 2. We want to make water, that's B. That's also 2. And again, we're going to be using 1 mole is molar mass. We said oxygen was 16. Hydrogen is 1. We have 2 of them, 16, 17, 18. Let's see, and we're starting off with 32. My grams cancel, my 32s cancel. Mole A cancels, mole B cancels. We're left with grams. That's good. 2 and 2 cancel because they're on top of each other. If I have 2 over 2, that's 1. 1's cancel. So we would get 18 grams of water because that's what our B is. So the setup is going to be exactly the same. The only thing different is going to be the values of those. So again, I'll change my color so that we can tell that it's a different reaction. So if we start with 32 grams, we'll call you A2 of methane, of A2. Based on the map, we're going to go mole, mole, mass. So we'll have mole A2, mole B, and then we wanted grams of B. We'll slide everybody down. So I'm still going to use 1 mole is molar mass. Carbon, I know that mass is 12. I know hydrogen is 1, and there's 4 of them. 12 plus 4 is 16. Let's see, my coefficient of CH4, no number means 1. Water, that's still the B, that stays the same. 1 mole, if you see the grams, that's always molar mass unless it's a given. And that stays the same, that's 18. So let's see, grams and grams cancel, those don't cancel. Moles and moles cancel, 1 and 1 cancel. Mole B and mole B cancel. And that's it. So we'll have 32 times 2 times 18 divided by 16. So that's going to give me 72 grams of water. Well, that would be great. You can only make as much as your limiting reactant lets you. So you can only make as much as your least amount. So we can only make 18 grams. That's how much we can make, and that would make oxygen our limiting reactant. It's kind of like if I have 10 pieces of bread and 2 pieces of ham, I can only make 2 sandwiches because I'm limited by my ham. I can only make it because that's as much as the ham will let me make. So because of the amount of oxygen I have, I can only make 18 grams of water. So if you see limiting reactant, automatically you're going to have to make 2 tables. They might tell you the product that you're going to looking for. They might not. If not, then just pick the easiest one. And then whichever one produces the least, that's your limiting reactant, and that's how much you can make. And that's all we have to say about stoichiometry in general. If you still have questions, send me a message and we can work it out.